And I'm sorry, the battery died, so now you should be good. 7.1.8 slope. On your student side, you're going to be writing down two things. I would like you to use color. Okay, so there are two ways to calculate slope, and it's really actually pretty simple once you start working on it. Okay, there are two ways to work and calculate slope. They're on page 74. Okay, bless you. So traditionally, what it means is the rise over the run. And I'll show you what that means in a second. So rise over run should be in your notebook in color somewhere, or bubble, something. Rise over run. Rise over run. Now, if we take a look at an coordinate plane, if I have a line that's straight, use your vocabulary words, use your context clues. Which one do you think is rise and which one do you think is run? Which one do you think is rise and which one do you think is run? X or Y? Max.
The y-axis is the rise.
Very good.
X-axis is the run.
Awesome. See how it's rising? And then if you did it this way, it's kind of like you're running. Okay. So it's y over x. Y over x. So that's the traditional math way to say it. It's rise over run. Okay. To help you, I'm going to give you a more simplified definition of it, so that as you're working on this, it doesn't totally slap you in the face and you're like, I don't remember how to do this. Bless you. Bless you.
Bless you.
So, same thing. You're going to look at rise over run. The other way to write this, and this isn't really the mathematical terminology, but that's okay. The other way to write this is the change in y over the change in x. Change in y over change in x. Now you guys have been working on this with your what you did last night. So that's why we taught you that first. Now you're going to do slope. Okay. Slope gets a lot more complicated as you go through math. So this is actually the easiest part of slope. Hi. Yes, Megan Welsh. Okay, everybody got that written down in your notebook? Awesome, awesome. Okay. Below that, I'm going to ask you to draw a very simple XY coordinate plane. Just do quadrant 1. Make it very simple. Doesn't need to look pretty or fun or anything like that. Make it very simple. Whoops. We're going to count by 5s going up the rise, and by 1s going down the run.
An eraser.
You need an eraser.
Yes.
You don't have any do you want to charge for an eraser? $1. Okay. Ben, please remember to pay him $1.
Whoa. Oh, that was
That was also a donation from Mrs. Gill for the classroom, so please thank her if you ever see her.
Thank you.
Okay. Everyone's got your simple pimple coordinate plane written in there. Okay. What did we talk about yesterday with constant rates of change? You have to have what with your line?
It starts from your origin.
It starts from your origin,
And goes completely straight.
and it's a completely straight line. Okay? So we're going, and this is going to be really rough, so just hang in there with me. We're going to do, just go really diagonally. Don't slant it. It's going to be rough, I know. It doesn't look very pretty. Okay, so this is your constant rate of change. Could you calculate constant rate of change with this? Yes. Can you calculate slope with this?
Yes.
Yes. All right. On page 74, underneath their little chart, very bottom. Who wants to read the little snippet about count the number? Max, thank you.
Count the number of units that make up the rise of the line in the graph shows. Write this number for the numerator of the fraction below. Count the number of units that make up the run of the line. Write this number for the denominator of the fraction below.
Okay, so what you're doing is you're going to go up and over to the dots that you see. Okay? It is kind of easy. So we're going to say there's a dot here, so we can go right on 2. We're going to say there's a dot right on 4. And we're going to say there's a dot right on 6. Okay? So we're going to do rise and run twice. Actually, no. You can start from origin. But we don't have to. Okay, everyone's got that mapped out?
Yeah.
So we're going to have to approximate a little bit, so just hang in there with me. Okay, and I'll try to use the same colors that are in the book. Well, so let's start off with our rise. I want to go up my coordinate plane enough so that I hit the line that my next dot's on. Does that make sense? I only want to go up as high as my next dot. Yes?
Yeah.
Okay. Where about, and we're going to have to approximate in this case, where about do you think the rise is? Where do you think that dot would be if we put a dot there? Megan Fabro?
About 15.
It's a little bit higher than 15. So let's say 16. Okay. So let's say that this is 16. We're just going to pretend. This dot, where would you say that is? Where would you say that is?
14, 15.
No, it's between 5 and 10.
Oh,
I would say it's about 6. Okay, does that make sense? Okay, so what is my rise? 16 minus 6. That's it.
Oh, sweet.
10. Okay? Yes, sir.
Okay. There's no colors.
That's right. Sorry. I keep reading, you guys don't see the colors. The rise is always blue. See how it's a little bit shaded in? Red's darker. Sorry, I keep forgetting. Okay. Then do the run. So I want to run from here over to my dot. Does that make sense? I'm just running over from that line to the dot.
Yep.
Okay. So I started at 2. And then this is going to be about, oh no, actually I did those exactly. That is,
4.
Gabriel, thank you,
4.
4. Is 4 the rise? I'm sorry, is 4 the run, I mean? Gabriel? Griffin?
I still need a different than that. And yes. Wait. No.
No, because I want to subtract. Other way. 4 minus 2. What's the distance between those two dots? So 4 minus 2. So your run is,
2.
Nicholas,
Two.
2. Okay? Now, you can only do this when you have a constant rate of change. And this is where I said this graph's going to look a little bit wonky. This should, if it was set up appropriately, this should have a rise of 10 and a run of 2. And it'll keep going up 10, 2, 10, 2, 10, 2. Does that make sense?
Yeah.
If it doesn't do that, then it's not a constant rate of change and you can't calculate the slope. It's got to keep going the same. It has to have the same rise, same run. Same rise, same run. Same rise, same run. Yes?
Yeah.
Okay, so my slope is 10 over 2. Can I leave it like this? No. Why? Seth, can I leave 10 over 2 as my slope?
No.
Because it can be... Seth can answer. It can be simplified. So what's 10 over 2 simplified, everybody?
5.
5. So my slope is 5. Okay? It really is that easy.
Mine's 7.5. Mine's 7.5. Oh, well, my graph is 2.
You didn't count by 5s and 1s?
No, well, yeah, I did, but no, it's just not. It's just like the 2 is on the 10, the 4 is on the 25, the 6 is on.
Let's say it like this.
Well, I know.
If they gave you... It's fine. It's fine. We're working through this. Let's say that your coordinates were... Or your...
Still got it right.
I don't remember. Let's say it's 10, 2. Never mind. We'll go through this.
It's not even possible.
Do you
Well, yes, it is possible.
do you understand though how we got the slope down here? Rise over run. Okay. Griffin.
So, for slope, do we only take the measurements from the top one on the slant line, or do we take slope from any of the other ones?
It's rise over run.
I know, but there's multiple different ones on that.
They should be the same because it's a constant rate of change. Remember we just did that? It's
Oh.
constant. For every 10 it goes up, it goes over 2. For every 10 it goes up, it goes over 2. It has to be constant. Yes.
Are the, whenever we do slopes, are they always constant?
I'm hoping. I didn't look through this completely yet. It should be constant for you in the book. If it's not, we'll figure it out together. They should give you constants because you can't calculate slope otherwise. Yes.
So, I don't know if this is what she asked, but what if it's like zigzaggy?
It shouldn't be.
Could you still calculate the slope?
Not in 6th grade.
But
Not in 6th grade.
what do we learn?
Max.
So, when there's, let's say there's 5 dots, do you want us to calculate, like, 2, 1, all of
That's a
them?
good question. How many do you think you should do? How many rises and runs do you think you should do? Nicholas? You can, but what would be a good number to stop at? You don't have to do the whole thing. Sophia? 3. Well, 3 dots. 2 rises, 2 runs. 2 rises, 2 runs. That way you can be sure that it's constant. Okay? Especially if you're creating your own graph, you really want to make sure that you're doing more than one. Okay? The book graphs are hopefully going to be constant. I didn't see any that weren't. If you're making your own, you probably want to double check and make sure that it does it a couple times. Okay? Let's look at number 1. Page 75. The table below shows the relationship between the number of seconds y it takes to hear thunder after a lightning strike and the miles x you are from the lightning. Graph the data and find the slope. So, take a look at the miles and the seconds. First of all, you don't even have to look at that graph. Look at just your xy coordinates. Is that a constant rate of change?
Yep.
Yeah.
I didn't say go. Go. Yes, that is. Is it going to be a line that we can work with because it goes through the origin and it's going to be straight? Yes. You can automatically tell. Why? Because the first coordinate is, Ellen? 0, 0. So that shows me that that's going to be a constant rate. Okay? Questions, comments on that one? Yes, no, maybe so? Okay. Do you see how they've calculated a rise and a run? Go. You do see their rise and their run? What was their rise? They went from what to what, Griffin?
15 to 25.
15 to 25. So their rise was
10.
10. And then Cheyenne, what did they do for their run? They went from
3 minus 5 to
They went from 3 to 5, right? So 5 minus 3 is 2. So they got their fraction 10 over 2. I didn't do that on purpose, I swear. That was quinky dink, but mine is 10 over 2. And they simplified it to 5 over 1. Okay? So that's our unit rate. Every 5 seconds, there's a mile between you and a lightning strike. Which is true, by the way. So if you see lightning and count by seconds, that's how far away it is. 5 seconds is 1 mile, 10 seconds is 2 miles. If it flashes and it booms, you're probably already in the storm, but hopefully you already know that.
I can't remember the last time I was actually in a thunderstorm.
If you hear thunder within 5 seconds, that means get inside. 10 seconds, I'd start getting ready.
Oh, Max spinning over.
I didn't ask for a story. All right. I would like you to try letter A, please. Is it a constant rate of change? Go. Does it go through the origin? Yes. Does it? Warning. Does it go through a? Or does it? Is it a constant rate? Can I calculate slope? Wonderful. Get to work. Please do at least 2 rises and 2 runs to make sure that it's correct. Can you guys see the? Oh, it's not graph for you. Just kidding. Graph it first.